In this video, I am going to use derivatives to find the optimal number of units that a business should sell per month in order to maximize their revenue. So let's assume that there is a business that sells 1000 units per month, some product at a price of $100 per unit. But the market research showed that if they reduce the price by $5, then the sale increases by 10 units. What is the quantity the business should sell per month to optimize their revenue? That means they want to maximize their revenue. Now, let me remind you of the revenue function. R of x is equal to x times P of x. X is the number of units that you sell, and P of x is the price per unit at x, meaning that it is a variable that is dependent on how many units you sell. If there is an oversupply of something in the market, then the price is going to fall. If there is an undersupply of something, the price is going to increase. Okay, so P of x is the price per unit as a function of the quantity that you sell. Notice that they tell you for $5 decrease in price, they sell extra 10 units. So per unit decrease. So per unit decrease in price is going to be 5/10, which is just 1/2, right? So per unit decrease. So now let me get a price function, P of x. So P of x, original price was $100, right? So 100 minus, now you have to think, how is the price changing? So remember, per unit is changing $0.50 or 50 cents. So how many extra units are you selling? That's going to determine what the new price is going to be. So let's say 1/2 times, now let's say x is the total number of units that you sell. Okay, x is the total number of units you sell. Then the additional unit you're going to be selling is going to be x minus 1000. Why 1000? Because remember, you used to sell 1000 units before. So that's going to be your new price function. So x is the variable. So if I were to simplify it, I get P of x is equal to 100 minus 1/2 x, or x over 2, plus 500. So that's going to give me P of x is equal to 600 minus x over 2. Now, what is the revenue? Revenue is x times P of x. So I'm going to take this revenue function, R of x is equal to x times P of x. My P of x is this, so it's going to be 600 minus x over 2. That is going to be 600x minus x squared over 2. So my R prime of x is going to be 600 minus x. Now I need to set it equal to 0. Why set it equal to 0? Because I want to optimize R of x, right? So that implies that my x should be set at 600. Now this 600, is it a local max or local mean? We need to figure that out. X is equal to 600. We can find that out by taking the double prime of r. That means taking the second derivative of r, which is going to be just -1. So that means r double prime is less than 0. So by the second derivative test, the function is concave down here, so it's going to be a local max. Local max. This, by the way, also will be a global max, because look at our revenue function. It is a parabola, right? So what it is going to do is going to give you the global max as well. So if I plug in this value, okay, x is equal to 600, x is equal to 600 into my price function, P of x is equal to 600, which is this function, by the way, 600 minus 600 over 2, which is going to give you just 300. Now, I noticed something interesting here. The price should be at 300, but initially we were selling at 100. So we should probably increase our price um, and decrease the quantity that we sell. So let me do a quick check. So previously I was selling 1,000 units at $100. So that was bringing in 100,000 in revenue. Now I'm selling 600 units, but at $300 a piece. So that's gonna give me 18, followed by, yeah. So looks like we are gonna be selling, maximizing revenue at when we sell 600 units at a price of $300, and the revenue is gonna be $180,000. I hope that this discussion was helpful. Thank you very much.